All right, algebra students, in this video we're going to talk about function notation. Now, the good thing is that function notation is just another way of writing some equations. And so anytime you have an equation where it says y equals, and you can rewrite that so that it basically says, well, it looks like this, and the equation part is going to stay exactly the same. Now, the way we read that, and because the way that you'll hear me read it a lot on this video or whatever, is that it's read as f of x. F of x equals, and then whatever follows after that, okay? So instead of saying y equals, f of x equals, and it's because it's a function, and it's in function notation, where f of x, that is your output. Okay, just the same as like putting y equals or whatever. And x is what you are plugging in as your input. Otherwise, it's exactly the same as what we just got done doing. Okay, so a lot of times we see it where it looks like this, where you have f of x is equal to 4x minus 1, and it says to find f of negative 7. Well, what you did was, or what they did, I guess, is they took out the x and they put in a negative 7. So f of negative 7 would be equal to 4 times negative 7. You're taking out that x and you're plugging in a negative 7. And so everything else is just kind of order of operations. So it's 4 times negative 7. That's a negative 28 minus 1 would be negative 29. And so f of negative 7 would be equal to negative 29. All you're doing is you're plugging in. So it's really not too bad, I hope anyway. F of 5, uh-oh, I didn't write that correctly. F of 5 in this equation that we have where it's x plus 7, that would be 5 plus 7. And 5 plus 7 is 12. So f of 5 would be equal to 12. That's your final answer. Okay? All we're doing is we're plugging it in. Now, it doesn't have to be an f. A lot of times if you use f, then the next thing that you would use would be g. And so g of x, or g of negative 3, when it's equal to 3x minus 8, would be 3 times negative 3 minus 8. And again, it's order of operations. 3 times negative 3 is negative 9. Minus 8 would be a negative 17. I'm not going to write the other stuff anymore. Hopefully you guys get it. And there we go. Fractions. I know you guys love fractions. If you get done using f and g, a lot of times you use h. H of 9 would be equal to 2/3 times 9, and then subtract 1. Don't be afraid of fractions. Just try to reduce them if you can. 3 goes into 9 3 times, and it ends up being 2 times 3, which is 6, and then 6 minus 1 is 5. So g of 9 would be 5. Number 4, we've got x squared, and actually there's two x's in here. Okay? So f of negative 4, when we plug this in, it would be negative 4 squared minus negative 4. I'm going to use parentheses there just to kind of keep it separated a little bit. Now, negative 4 squared is 16. And this minus a negative, you can change that into plus a positive, so it's 16 plus 4. And so 16 plus 4 is 20. Be careful when you're squaring negatives, because negative 4 squared is a positive 16. All right? Moving on over, we've got a longer problem. Anytime we have multiple x's, everywhere where we see an x, we're plugging in a 5. So it's negative, and this time it's 5 squared, but it's not negative 5 squared, okay? It's negative, and then in parentheses, 5 squared. That's going to end up being a little bit different than the last problem, plus 6 times 5, and then minus 4. Now, what you do is you square the 5. And if you square the 5, you get 25. And so then the negative just kind of comes along with it. So it would not be a positive answer because that negative was on the outside of the parentheses. 6 times 5 is 30. So plus 30 minus 4. Now we can just go straight across. Negative 25 plus 30 is 5. 5 minus 4 is 1. So f of 5 on that function would be 1. Okay? Basically, if you were to see these graphed, you would see either a straight line or a curve on all the ones that we've done so far. By the way, I'm going to keep on doing number 6. And this is an output if you were to plug in negative 8, for instance, on number 6 for x. So 1/2 times negative 8, and then add 9. Again, we can reduce here. 2 goes into 8 4 times. It's a negative times a negative, so it ends up being a positive 4 plus 9. And positive 4 plus 9 is 13. So if we were to plug into and take a look at this graph at 1/2 x plus 9, if we were to look at it where x was negative 8, the y output would be at a positive 13. Okay? Number 7. Again, everywhere where we see an x, we're going to plug in a negative 5. So it's 2, and then negative 5 squared plus 4 times negative 5 minus 9. Negative 5 squared is a positive 25, so it's 2 times 25. And then minus 20, because 4 times negative 5 is negative 20, and then minus 9. Then you got to do this other multiplication. That ends up being 50 minus 20 minus 9. 50 minus 20 is 30. 30 minus 9 is 21. Okay? And then lastly, on the front side is we've got an absolute value thing. It's okay. We're just still going to do it the same way. Don't have to do anything crazy because we're not actually like trying to do anything with this. We're just plugging in and then simplifying it. So we don't need to split it up and do the opposite or anything like that. We're just going to keep these absolute value bars until we get it all the way done. So negative 7 squared is a 49, but there's that minus out in front, so I'm going to keep it like that. Okay, negative 7 minus a 49, well, that'd be a negative 56. And then the absolute value of negative 56 is a positive 56. And so your absolute value would be, or I'm sorry, g of negative 7 would be positive 56. Okay, let's flip it over on the back and see what we got on there. On the back, it's going to start off about the same, except it does get a little crazy. But here's what we need to understand. All of this stuff that we have f of, okay, f of x is equal to, in this case we're plugging in c plus 7. We're going to plug that in for x, okay? So f of c plus 7 is equal to 4 and then c plus 7. I replaced that x with the c plus 7 and then plus 11. Now simplify it if you can. So we would distribute next. So it would be 4c plus 28 plus 11. And then combine like terms if you can. So the 28 and the 11 would combine, so you end up getting 4c plus 39. So f of c plus 7, even though it's not just a number, we can simplify it down so that it is 4c plus 39. Same thing goes for number 10. Okay, now by the way, this is kind of upper level stuff. If you don't get it, this will only show up, these 9 and 10 will only show up on the A version of stuff. Just so you know, okay? We're not talking about F, we're talking about H. So H of 2k minus 5 is equal to negative 9 minus 2k minus 5. Hopefully what you see is that we know how to do these. We have done these before. Minus means we're going to turn these things into pluses. Okay, we're going to turn it into a plus, and we're going to change the sign and every single thing inside the parentheses. So you end up getting negative 9 minus 2k and then plus 5. And you can combine like terms with those. So you end up getting negative 2k minus 4. Okay, and that would be your final answer when you plugged in the 2k minus 5. All right, now down at the bottom, it's got some other things, okay? So we're going to use these functions that we have over on the left, and basically we've got f of x is equal to 8 minus 3x. So what we're going to do is we're going to evaluate what it is at f of 4 first. And then we're going to take that and we're going to add 9 to it, okay? So if f of 4 is basically 8 minus 3 times 4. We're going to do that first. Okay, so that would be 8 minus 12, and that's a negative 4. And then, don't forget, you've got to add that 9. So we're going to add 9 to the tail end of it, and you get a positive 5. So you take and you do the function first. And then whatever it tells you to do outside of that function, in this case plus 9, you add it to whatever you got on the inside. Okay? Number 12, you're going to have to multiply. So, but we're still going to do g of negative 5 first. So g of negative 5 means that it's going to be negative 5 squared and then plus 2 times negative 5. All right, so if I simplify this, that's going to be 25 minus 10, and then 25 minus 10 is 15. Now, that doesn't take into consideration this negative 2 that I had out on the outside there. So I'm going to have to multiply that times negative 2. And when I multiply that times negative 2, I get a negative 30. Okay, so I tried to write it similarly to the way they had it at the very beginning of the problem. But the answer is negative 30. But you take care of the function first before you add or subtract anything to it. Now, what we're going to do with 13 is we're going to evaluate both of them, and then we're going to add them together. Okay, so it's g of 4. Now, the g function was 4 squared plus 2 times 4. Okay, now let's simplify this one down. That's 16 plus 8, and 16 plus 8 is 24. Okay, that's our g function, or g of 4, I mean. If I did the same thing, but now g of negative 1, it's the same function, but it's negative 1 squared. I'm going to run out of room. But plus 2 times negative 1. So that ends up being a positive 1 minus 2. 1 minus 2 is a negative 1. So basically now what we're doing is we're gonna combine these two, because it said it was plus in the middle. So it's 24 plus negative 1, which ends up being 23. So your final answer, almost ran out of room, is a positive 23. Okay? All right, let's take a look at question 14. Question 14. So it looks like we've got two different things going on. We've got 3 times h of 2 and f of negative 9. So what we're going to need to do is we're going to need to first, or I guess we could do this in out of order, but what I'm going to do is I'm going to figure out what h of 2 is. Okay? H of 2 it would be negative 5 over 2. Negative 5 halves, there's a negative out in front of there, times 2, and then subtract 1. Okay, that's what it was, minus 1. So let's figure out what h of 2 would be. Now, these 2's would cancel, and that ends up giving us negative 5 minus 1, which is negative 6. Okay, so h of 2 is negative 6. Now we're going to figure out what f of negative 9 is. F of negative 9, that is that 8 minus 3. So 8 minus 3 times negative 9. Negative 3 times negative 9 is going to be a positive 27. And so 8 plus 27 would end up being 35. So let me write that in there. Now here's what we've got. We've got 3. I'm going to rewrite this. So it's 3 now times negative 6, because as you go across here, it's 3, h of 2 was negative 6. So 3 times negative 6, and then minus 35. Okay, so it's a simpler problem. It's an algebraic numeric problem. So 3 times negative 6, it's negative 18. And then when we subtract 35, we've got 2 negatives, which means it's going to be a bigger negative, which ends up being a negative 53. Okay? So hopefully that makes sense. You're going to have to figure out what the functions are first. Evaluate the functions. H of 2. What is that? Well, that was negative 6. Well, it was 3 times negative 6. Okay? And then subtracting whatever f of 9 is. Well, f of 9 is 35. And so when you do all of that, you end up getting a negative 53. Okay? 15 and 16 are a little different. And it's because they're not plugging in for x anymore. What they're doing is they're telling you that the output is negative 13, but they're asking you to try to solve for whatever that input is, and that input is x. So f of x, that function that we have, if you look up at the top, it is 8 minus 3x. Okay, that is our function. That is f of x. Okay, so it's basically like I'm taking this and I'm going to plug this in. F of x is equal to that. So that's equal to negative 13 is what this tells me. Okay, so there's where I'm getting both of those numbers right there. Okay, f of x up in this bubble up in this bubble, it tells us that f of x is equal to 8x, or I'm sorry, 8 minus 3x. So I'm just substituting in. Now it's a regular old problem, so I'm going to subtract 8 from both sides, okay, and then you get negative 3x. Negative 13 minus 8 is a negative 21, and then if you divide both sides by a negative 3, you get x is equal to 7. So when you're finding out what x is, the input, you're setting that negative 13 equal to the function itself, and you're solving, okay? I think these are a little bit easier than questions like number 13 and 14. You're just setting the whole entire thing equal to it. So on number 16, it's h of x. H of x is negative 5/2 x minus 1. And then that function is equal to, this thing is telling us it's equal to 39. So we're going to solve it. So we're going to add 1 first, and that gives us 40. So you get negative 5/2 x equals 40. And then to undo this, you need to multiply by negative 2/5. Okay, so both sides times negative 2/5. Remember, when we have a fraction out in front, we multiply by the reciprocal, and that gives x by itself. Problem is, I got to deal with this fraction on the other side. Okay, you could type into the calculator. You could actually type into the calculator 40 divided by 5/2, but 5 goes into 40 8 times, so 8 times negative 2 would be a negative 16. So x would be equal to negative 16. There you go. Now, down at the bottom of the page, we've got some things that are a little bit different. Okay, first of all, it's an application kind of problem. Let me read this for you. First off, it says anthropologists used the length of certain bones of human skeleton to estimate the height of a living person. One of these bones is the femur. To estimate the height in centimeters of a female with a femur of x length, the function h of x is equal to 61.41 plus 2.32x can be used. Find h of 46 and explain its meaning. Okay, well, it gives you all those words and everything, but then it doesn't, gives you the function, so you don't have to actually come up with anything. That's kind of nice. It says to figure out what h of 46 would be. Well, we're going to plug in 46 for x, and we're going to solve and figure out what it would be. So 61.41 plus 2.32 times 46. Let me grab my handy-dandy calculator. We'll see what this would be. 2.32 times 46 is 106, I'm going to rewrite this, is 106.72. And then when I add that to 61.41, that gives me 168.13. Now, if you look at, it says to explain its meaning. So it's 168.13. Look at the problem that we had. It says one of these bones is the femur. To estimate the height in centimeters of a female with a femur length of x, sorry. So basically, when the femur measures 46 centimeters, then the person's height would be, or in this case, it actually says a female too, then the female would be 168 centimeters. Okay, so if a female has a 46 centimeter femur, that's in your leg, it's a bone in your leg, then she should be 168.13 centimeters tall. Something like that. Okay, that's what this word problem is trying to get us to do. And that's the good thing about some of these functions, is that you can use functions in real life. Now, you might not actually ever see that kind of function. It might be in a computer program, but it's good to be able to know where it's coming from. Okay, next thing, last thing, number 18 and 19. We're given a graph. So we've already got the graph on number 18 and number 19. If you look here, they're trying to get us to figure out what the output would be at f of negative 3. Okay? Well, here's what it is. If you were to go on the x-axis at negative 3, so let me count over there. 1, 2, 3. And I go to where this graph is, and the graph would end up being in a point right there. So where x is negative 3, what is the y output? Well, it's up 2, so the output would be 2. Okay, it's basically at an ordered pair of negative 3, 2. That's what we're looking for right here. We're looking for where the graph is, basically, for part B, where would the graph be at 1? Well, if you go over 1 and you look up here, right, and that's where the graph is, this curve, and it is up 2 from the axis. And so that's also at 2. Okay, it can be the same number, that's fine. All right, f of 0. F of 0 is right smack dab in the middle, so you're not moving right, left, up, or down, or anything like that. So 2, 3, 4, 5. Okay, it's up 5, so f of 0 would be 5. And then lastly, f of 2. So over 2, well, that'd be right there. So 1, 2, then down 1, 2, 3. Looks like it's down 3, so at negative 3. So you're just trying to pick out, I think looking at the graph, it can be a little bit easier because you're just looking for where is the output, where is the graph at those x values, okay? And the x values are inside the parentheses. Where is the graph at those x values? Let's try again. Number 19, at negative 4. 1, 2, 3, 4. Well, the graph is up 2 right there at a positive 2. At 0, the graph is at, it's at no height. It's not up or down, so it is at 0 also. If we move over to the right 2, 1, 2, well, then the graph is down 2 units at negative 2. And then lastly, if we were to go over 5, 1, 2, 3, 4, 5, the graph would be at negative 1, at a height of negative 1. So my output is negative 1. There we go. So it's just looking at the graph and trying to interpret some stuff. So we've dealt with functions now, and we've dealt with equations for a little bit where we've simplified some things. This is really no different. It's just a different way of seeing some things. Function notation, f of x is the same thing as y equals, and we're going to do more and more of this as we go on. But hopefully it makes sense. If you have any questions, please let me know, and I'll be happy to help if I can.